Hi, well, I'm here to help you out with another additional problem from the homework set this week. This one has to do with how high a column of mercury will stand when the configuration is what's called an open barometer or an open manometer configuration. And for that purpose, we're going to use the hydrostatic equation, which I've written down here. So here's the physical setup, and this is a typical manometer, which we have in the laboratory. There's an inverted tube here, and it's mostly filled with liquid mercury, and it's sort of stuck into a little puddle of mercury there. And but it doesn't go. The mercury doesn't go all the way up to the top of that closed tube, and in fact, there's very close to a vacuum up there. So there's no pressure being exerted on there. And why does that column of mercury stand up so high? Well, the answer is that there's pressure that's being exerted on the puddle there that pushes it up that way. So the real relevant distance here is the height of the puddle, at the top of the puddle, to the top of where the mercury stands, and this is where you would read it if it were a conventional barometer. So that's the H that appears here in this equation, in the hydrostatic equation. The density would be the density of liquid mercury, and G is just the gravitational constant. So the first thing to do, since what you want to know is that height, is to solve this algebraically for the height. That's pretty easy. Just divide by rho G on both sides. So I've got that. Now we want to actually do a calculation. Now what we're told is that the pressure is 1 atmosphere, but I'd like to make this into an SI calculation because it's a little bit easier to do it that way. So that means I have to convert from atmospheres to pascals, and that's that right there. That's pretty straightforward. It's just going to be 1.01 times 10 to the 5th pascals. Now what are we going to do about the density? Well, the density in SI units would have to be kilograms per cubic meter. And if you look up the density in your text or in Wikipedia, you'll find that the density of mercury is 13.5 grams per mil, or grams per cubic centimeter. So if you want, make a pause this video right now and set up these conversion factors. Okay, assume you're back here. The first conversion factor, I'm going to try to replace the grams with kilograms, because kilograms is the SI unit for mass. And I know, let's see, there's 1 kilogram in every 1,000 grams. Okay, that's good. Now we'll get rid of the grams. Now I have a cubic centimeter downstairs, so I need to put a conversion factor over here. I'm going to put, I know that there's 100 centimeters in every 1 meter. That almost gets me there, but here's the deal. I've got cubic centimeters downstairs. And so what you need to do is cube this whole thing. What that's going to do is cube that number. That's 10 to the 6th. Centimeters cubed will get canceled out. We'll get cubic meters downstairs, kilograms upstairs, and that's that. So once you do that, then you will have the density in SI units. You'll have the pressure in SI units. Since everything on the right of this equation is now in SI units, when you get an H, we know that that's a height, so that will be in meters. And hopefully you'll get something like 0.76 meters if you've done it all right. If you convert that into millimeters, 0.76 meters is 760 millimeters, which is the same as torr. Okay.